Good morning. How are you guys? Yes? All right, let's see if I remember anybody's name. Hiya. Right there. Okay, I haven't gotten to the back row yet, so I'll get to know you more today. Okay. Kai. Excellent. Matthias. Excellent, Matthias. So I have Hiya and Kai and Matthias. James. Hello, James. And Yenna. Right in front of me. Okay. MG is here. Finn is here. Cassia is here. Sarah. No, Sarah? Okay. Grace. Grace. Ning. Hello. Emily. Excellent. Greg is here. Cherry is here. Andrew is, oh, I have two Andrews now. So Andrew Kim is here, and Andrew Vanderdusen is also here. That's okay, because I have two Andrews in my other class as well. I have an Andrew Ha and an Andrew Pan. I teach all Andrews this year. Let's see, Ethan. Ethan, excellent. Jenya is here. Catherine is here. Rio is here. Kaizen is here. G1 is here. Yes, good. And other Catherine is not here. No, okay. Alrighty. Well, I think I did that well. Not badly anyway. So I just wanted to show you very quickly our site here. Oh no, that's the wrong one. That's the science department one. This is us. Because we have a good cheap calculator if you need one. That is on our general team there. And also I am putting up corrections to the answer key as we go. So if you're like, hey, I have something that I think is wrong with the answer key, you can always reply to that and let me know, and I will put them up there and make the corrections so that in the future there will not be mistakes like that. So for example, 1.4a, number 2e, it should say micrometer instead of millimeter. Oh goodness, imagine that. Okay, so that was it for that. Did everybody watch the video with Mr. Tyler DeWitt? Yes, okay, I would like you to please define for your partner accuracy and precision. See if you can tell the difference between the two. So have a little chit chat with those people who are near you. And if there is no one near you, feel free to walk over to someone, okay? Or lean over, or your partner's not here. You can turn around too, yeah. Alrighty, would anyone like to tell me what accuracy is? Yes. Yeah, how close you are to the target. So if you've got like a dartboard, you would be like really close to the bullseye at the center. So how close you are to the actual value. And isn't it nice that accuracy starts with ac, and actual also starts with ac. So this is how close you are to the actual value. How close a measurement is all right. Precision. Anyone want to give a try on precision? Use the dartboard analogy if you like. Yes? It's how consistent you are, absolutely. So if you're talking about precision, it always implies that you have done more than one measurement, okay? So it's how close, how consistent you are. That's an excellent way of putting it. How consistent a set of measurements are. A set of measurements are. And it is also how close those, you could also say it is how close each set of, each of the measurements are to each other. How close a set of measurements are to each other. Now I'm going to draw a little dartboard here. Okay, there's the center. Not very good at drawing. Let's try that outer one again. There we go. Okay, so let's say that I have this, and let's say that I have a point here, and here, and here, and here. This is kind of like the weirdest situation. What could you say about the accuracy? Is that accuracy high or low? Tell your partner. What do you think? Accuracy. And once you've talked about accuracy, you can also talk about the precision. In fact, let's start with the precision. Let's start with the precision. What do you guys think? Precision, high or low? Definitely the precision is low. I don't know why my pen would not draw a circle there. There we go. Definitely low. Now, accuracy, you could say that each individual dart on that dartboard, was it accurate or inaccurate? Each individual dart. They are inaccurate. So low accuracy. However, what if we were to average that set of darts? Where would you find the average of those set of darts? The average would be right at the center. Okay, So this set of measurements, if I was to present this to you as a set, the set of darts is high accuracy. Since the average is close to the desired target. Now, if we weren't throwing darts, but we were actually, doing measurements in a lab and we're trying to get some good results, and we had results that were really far away from each other, even if we got the right answer, that wouldn't be particularly great data, yeah? Because it might just be like by accident that you got them really close to one another, yes? So you would probably, if you were actually doing a lab in the real world, you would probably do your experiment again to see if you could get better data. We probably won't do that a lot here because we have to complete our lab usually in one class period. So it's like whatever data you get is the data you get, okay? So that was accuracy and precision. I would like to have a quiz on that on Monday. Yes, Monday. So in between now and Monday, there is the accuracy and precision worksheet, which I'm going to assign tonight. So that's 1.2b is one of the things that you're going to do. And then on the weekend, probably it would be a good idea for you to do a review with the extra practice accuracy and precision. Yes? Don't worry, I'll write this all down at the end of class. I'll also, hey, how about if I put it on Teams right now? And I've discovered I can afford to waste a little time in this class because block 4 is shorter and I can't finish things with them. So if I spend a little extra time in here doing things like putting things up in homework, no, upcoming quizzes and tests, there we go. Oh, look, Thursday, there is a quiz on SI units and metric prefixes. Okay, yes, I remember I told you there would be a lot of quizzes. Let's take a look at this, see more. So you should have gotten a notification about this. Do check your email on a regular basis. Let's make a new conversation here. And we have, that would be Monday, February now let's see. If Thursday is the 2nd, that would be 3rd, 4th, 5th, 6th. And that will be a quiz on accuracy and precision. There we go. Excellent. There we go. There we go. Okay. So that was accuracy and precision. I would like to finish up with our exponents today. So last day we did all our positive exponents. How did you guys feel about that? Did you have any questions when you did page 105? Because if you did, we could go over those today. I know there's a couple of weird ones near the bottom. And 1.6, that was page 105. Any questions from page 105? Going once, going twice, going 3 times. Sold. All right. Oh, I remember the other thing I was going to do with you before we do anything else. We are going to go to our study techniques. I'm going to try and do one at the beginning of every class for the following week. because there's a whole bunch of tips in here, scientifically based, for how to do better on things. So, number one, put your phone away for better grades. Let's see what they have to say about this. This is a study out of the University of Texas. Now, why is it not going there? Hello? Oh, it is going. It's just taking a while. Verifying link. There we go. Okay, out of the University of Texas. Your cognitive capacity is significantly reduced when your smartphone is within reach, even if it's off. This is the takeaway from a new study out of the McCombs School of Business at the University of Texas at Austin. So they did experiments with nearly 800 smartphone users in an attempt to measure for the first time how well people can complete tasks when they have their smartphones nearby, even when they are not using them. Okay? So this means it's just sitting on your desk, can be turned off, it's just there. In one experiment, the researchers asked study participants to sit at a computer and take a series of tests that required full concentration in order to score well. The tests were geared to measure participants' available cognitive capacity. That is the brain's ability to hold and process data at any given time. Before beginning, participants were randomly instructed to place their smartphones either on the desk face down, in their pocket or their personal bag, or in another room. All participants were instructed to turn their phones to silent. The researchers found that participants with their phones in another room did significantly outperform those with their phones on their desk. And they also slightly outperformed those participants who kept their phones in a pocket or a bag. So if you have your phone on your desk right now, what should you be doing with it? Put it in a pocket, put it in a bag, and if you are unable to manage yourself to do that, I will be inviting you to use the Cell Hotel. Okay, everybody has a name up here. All right, you guys are on the first row because you're period 2. You are blue, and you're up here in alphabetical order. So we have the B's, the C's, the D's, E, F, G, H, all the way across. All right, so if you have trouble with your cell phone, you will be invited to use the Cell Hotel. I believe that as grade 11 students, you are probably capable of self-regulating enough to put your phone in your pocket or your bag once class starts. Okay, before class starts, do I care? No. All right, if you finish all your work early, let me know so I don't come and hassle you. Why are you on your phone? I'm done all my work. Well, oh, okay then, right? I don't want to do that. It's awkward for everyone. All right. So at any rate, just a few more details here. Findings suggest that the mere presence of the smartphone, not looking at it, not doing anything with it, whatever, is enough to, it reduces your cognitive capacity, it impairs your cognitive function, even though people feel like they're giving their full attention and focus to the task at hand. So you might think, oh, it's not going to bother me. I'm not worried about it. But it's like any kind of addiction, and yes, most of you are probably addicted at least a little bit to your phones, okay? It's like any other kind of addiction. It's kind of there in the back of your mind. The phone is like speaking to you. Pick me up, I've got something here. Hello, I'm over here. Talk to me, look at me. Okay? There is a linear trend that suggests as the smartphone becomes more noticeable, participants' available cognitive capacity decreases. You could do even better if you were to go put your phone in that room over there, but that seems unreasonable. So your pocket or a bag will do quite nicely. In another experiment, researchers looked at how a person's self-reported smartphone dependence, or how strongly a person felt he or she needed the smartphone in order to get through a typical day, affected cognitive capacity. Participants performed the same series of computer-based tests as the first group and were randomly assigned to keep their smartphones either on the desk, in the bag, or in the other room. In this experiment, the phones were also turned off. Researchers found that participants who were the most dependent on their smartphones performed worse compared with their less dependent peers, but only when they kept their smartphones on the desk or in their pocket or bag. So if you feel like you are very dependent on your cell phone and you would like to do better in school because you know that grade 11 grades go get reported to universities and so on and so forth, just try cutting back. You know, make it like, okay, when I'm in class, that phone is not anywhere near me, right? When I'm at home, maybe I'm going to like set out blocks of time where I'm like, I'm just not going to be on my phone from, 3 till 4 in the afternoon, or whatever time it works out. The less you can be dependent on it, the better your cognitive function, the better your grades. Okay? Anyway, that was research out of the University of Texas. Hopefully you find that helpful. If you don't, well, maybe I'll help you with it. All right. Back to exponents. Last day we did positive exponents. Today we are doing negative exponents and also the zero exponent. So we will go out, those are powers of 10, I don't want that yet. This is on page 106. Okay, page 106. What do you guys know about a number that you raise to the power of 0? It is equal to 1. So anytime you see anything raised to the power of 0, that is equal to 1. So on our very first example there, 4 to the 0, there is no way to write that as a positive exponent because 0 is just 0. It's neither positive nor negative. There is no expanded form. And the standard form, of course, would just be 1. Come back. There we go. That's better. Our second one. Do you guys know what it means when we have a negative exponent? What do we do with it? We flip it, okay? Anytime you have a negative exponent, if that negative exponent is in the numerator, you will move that number to the denominator and make it positive. If the number with the negative exponent is in the denominator, you can move it to the numerator and make it positive. So if we have 2 to the negative 1, to write that in positive form, we take 2 and move it down, okay? So it goes into the denominator. Denominator is just a really long word. I don't like it. I'm just going to call it denom, okay? And the exponent becomes positive. Exponent is too long too. I'm going to call it exp. And of course, anything raised to the power of 1 is just itself. So 1 over 2 to the 1 is 1/2. So if you see 2 to the negative 1, what that really just means is 1/2. And the standard form is just exactly the same. Okay, I'm going to write the next two off to the side. That is 2 to the negative 2, and then we have seconds to the negative 1. I have a negative exponent, so what am I going to do with my number? I'm going to move it to the denominator. Okay, there it goes. I'm going to make the exponent positive. Okay. And then I can expand this, and it just expands the same way as we did before. 2 squared is just 2 times 2. And if we solve for that, we get 1 over 4. Does this sound familiar from math class? Good. Have you seen anything like seconds to the negative 1 in math class? Maybe, maybe not. Okay, that's a little weird. And in fact, this is a unit that is used quite frequently in chemistry. Ha 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 ha. I'm laughing in that way because it is actually the unit of frequency. The unit of frequency is actually seconds to the negative 1. So has anyone learned about frequency in physics or anything like that? No? Do you remember in grade 8? Ha! 3 years ago. There, you might have learned about wavelength. Do you remember learning about wavelength? And you know the wavelength was the distance from one peak to the next peak, yes? And there is, so this one would have a shorter wavelength, yes? Now, if this entire wave was moving, okay, the frequency is how often a peak passes a point. Yes? So if I was moving this, ooh, look, I can do it. Here, let's be like, well, these are at the same place, yes? So we can be like, how long does it take to get from each one to each one? Oh, 1. The first one hit 2, yes? So we have 1, and then we have 2. But the second one has not hit number 2 yet, the bigger one with the longer wavelength. Okay? So the frequency is how often you see a peak as a wave moves past. Do you need to know this for chemistry 11? No, you don't. But if you're taking physics, you might need to know it. Okay? But it just means how many go past a point in a second. So the unit is how many per second. Whoops. Per second. And we don't say how many what, we just say how many whatever per second. Did you guys know that divide by means, per means divide by? Per means divide by, if you didn't know that. So in other words, what we have is we have something per second. Yes? And I'm just going to put 1 per second. Okay, so that's a per second. You don't need to write this down. This is not part of Chem 11, but it's kind of interesting. Okay? Now, that second, what power is that second raised to? It's raised to the power of 1. Yes? Now, what if I didn't want to write it in the denominator? What if I wanted to write it in the numerator? I could write it as negative 1. So that means per second. And that's what you measure frequency in. It's also called a hertz. Has anyone ever heard of hertz? Yeah? A hertz is a per second, or a second to the negative 1. And that is the unit of frequency. And if you're interested in that, that's awesome. And if you're not, thank you for bearing with me while I geeked out for a moment there, okay? It does happen from time to time. Okay, so that is seconds to the -1. So we will move the seconds to the denominator, and we will make the exponent positive, and so it's just 1/seconds. What if we had minutes to the -2? That would equal 1/minutes to the +2. And if we expand that, what do we do with our minutes in order to have minutes squared? We have minutes times minutes. Yeah, times minutes, and then we can't really do anything else other than put it back as 1/minutes squared. Okay? What if we have 2 times 3 to the -2? Who does the -2 apply to? Does it apply to the 2, to the 3, or both? Just the 3, okay? So what that means is that 2 is going to stay on the top, 2 will stay in the numerator. So 2 stays in the numerator, and we will move the 3 to the denominator and make the exponent positive. And from there, we have 2/3 times 3, which is equal to 2/, I almost wrote 6. Apparently I'm not really good with my powers of 3. 9. And finally, what if we had 3 times 2 to the -1 cubed? Well, before we get too excited about things, let's move things. Is the 3 going to move to the denominator, or is it going to stay in the numerator? Stay in the numerator. The 2, on the other hand, will move to the denominator, and that will become to the +1, which means we just have 2. Yes? There we go. I'll put it in there. And then that's all cubed. So you could write this either as 3/2 times 3/2 times 3/2, or you could write it as 3 times 3 times 3 over 2 times 2 times 2. And you would get 3 times 3 times 3 is 27, 2 times 2 times 2 is 8. And I think that's all for examples. What I would like you to do right now is pages 106 and 107. And when you are done that, it would be nice to be a little more active, I think, today, because you've listened to me a lot for the last 2 days. We are going to be doing equipment A, which is starting on page 3. You're going to have to get out of your seat to go find the names of equipment. So you're going to wander around and be like, oh, some of them have green signs. Okay. There's a little blue sign over here. A lot of the things are in labeled bins. Okay, so you can take a look and see what you can find. And if anything is missing, let me know. So take 106, 107, and then 1.1a. to label on. If you run into difficulty with any of the exponents, call me over. Some of them are a little weird, closer to the bottom of the page. Exactly. We don't need to actually. They have to release something. Your right now we're doing and then the homework is trouble finding something, it's possible that it is down here. This is sort of less glassware, more metalware, hardware, that kind of thing. Which one is which? Okay, let's pop that homework up there.